Okay, in this example for Chapter 9, I want to walk through the concept of net present value, internal rate of return, and equivalent annual annuity. And this is on page 282 to 283 of the textbook, but we're going to use the data values to show how to calculate each. First is for net present value. Net present value is the best method, in my opinion, for calculating worth of a project. But first thing we're going to do is I'm going to find out the present value of these cash flows in Excel. So if I go to f of x and I select net present value and hit OK, it's going to ask me for the rate, and the opportunity cost on this project was 10%. So I'm going to select 0.10. The values are the cash flow at the end of each year. So there's 500, 500, and 500. And we can see that the present value of these cash flows is $1,243.42. We hit OK. But in Excel, to find net present value, we need to net out the initial cost. So I'm going to say equals and click on my present value of the cash flows, and then I'll add the value that I have up here, the negative 1,000. So I net it out, and I find out that it comes to $243.43. With project B, we'll do the same thing. Find the present value of this cash flows. I'll do f of x, net present value again. Again, this is just our most recently used, but if you didn't, you could go into financial and find it, type in the letter N, and we'd get to it. So hit OK. Again, the rate is going to be 10%, and the values are going to be $300 in each of the years. So if you just hit tab, we'll go to the next one, and tab again, 300 again, just kind of repeating the process until we get 6 of them in there. Okay, so now we got all 6 in there. So it says the present value of cash flows is $1306.57. We hit OK. But again, we need to net out the initial cash outflow of the negative $1,000. So I'm just going to say equals, and then we'll click on the present value of the cash flows, and then add that negative 1,000 to it, and we get 306.58. So this does compare to what we have in the example in the textbook at the bottom, page 282. Now for the internal rate of return, there's a function in Excel. We go to f of x, and under financial, select internal rate of return. Find it here. So IRR, and by definition, IRR sets the net present value equal to 0. So it's looking for values. So what it's going to do, this is a big difference. Net present value we subtract out, but with values, we're going to highlight all the initial cash outflow and the following cash inflows at the end of each period. So I do it there. We get 23.37%. I'm going to hit OK. I'm going to format this cell out to 4 decimal places again. And it gives us a more exact internal rate of return. Again, internal rate of return by definition sets the net present value equal to 0. Same for this project. It had an internal rate of return of 23.38%. Do it right here for the same thing. I'm going to hit f of x, financial, find internal rate of return again, IRR. I'm going to hit OK. The values, I'm going to highlight negative 1,000 and the 6,300 cash flows for each year. Hit OK. Format that cell again to 4 decimal places. And it checks out to our textbook. The 19.9% is what they show, but we get a little bit more detail here. Well, another thing we could also do to make a comparison between 2 projects is we could use equivalent annual annuity. And sometimes it's also used for equivalent annual cost, but we're going to do it here to make a comparison for each time period. Because like the example of the textbook says, what if this project would repeat again? You do project A after 3 years, where this one is for 6 years. Well, what we could do is we could take the present value, net present value, and find a payment for that. So I'm going to go to equivalent annual annuity. Right below that, I'm going to go ahead and f of x, and I'm going to find payment. Type in the letter P, gets right to payment. I'm going to hit OK. Again, here it says the rate. Well, that's the rate that was on the project, so it's 10%. The number of periods is 3 years. The present value is that net present value. The future value is 0, so we'll leave it blank. And if I hit OK, and it says we get $97.89. So let's do the other one. So we can do payment again, financial, click in the letter P, get to payment, I'm going to hit OK. The rate, I'm going to choose my 10%. Number of periods in this is 6, and that present value is the net present value of 306.58. Okay. And again, yes, it does match up to the textbook because we have 97.89 and 17.39. The way to look at this is we'd actually prefer to have $97.89 each year as opposed to $70.39. So if we were able to repeat this Project A over again, the Project A would actually be the better choice. And one other thing I do want to point out, they do have the probability index there. And the probability index is a way that we can rank projects. But for the example, like in the bottom page 282, the probability index there, just looking at what is the initial cost here, $1,000 relative to the present value of these cash flows. Well, let's just kind of do that down here. If I took the present value of the cash flows divided by that initial cost of $1,000, we'll do it down here and show it. Format this cell just a regular number. We can see 1.24, or they kind of format to at least another decimal point, so that's where they get the 1.243. And we can do the same thing for the other project too. If I put in, again, the present value of the cash flows of 1306.58 divided by the initial cost of 1,000, and we're going to change the format of this cell to a number. And let's go out one more decimal point, and that's how they match up to the 1.307. So this should give you pretty much everything you need for this chapter relative to net present value, internal rate of return, and equivalent annual annuity to help make comparisons of projects. Again, probability index would say as long as the probability index is greater than 1, we would accept the project. As long as the net present value is positive, we'd also accept the project. Again, net present value is our best measurement for looking at decisions of projects. And that ends our example with page 282.